This R34 GT-R behind me produces 960 kilowatts at the wheels, despite being fully street legal, and it's run mid-nines at over 160 mile an hour on the quarter. We're going to chat to Adam from Just Engine Management and find out what makes this R34 GT-R tick. So Adam, 960 kilowatts, that's a huge amount of power from an RB engine.
Yeah. Let's
start with the engine. What have you done there?
Yeah, well, we've started off with a RB30 block out of a V8 Commodore and used a Spool 3.4 litre stroker kit, Platinum Racing Products girdle and engine internals to help strengthen it. And head-wise, it's still wet sump as well, using a Nitto oil pump. Head-wise, we've done in-house porting. It's been ported, it's got all the usual cams, gears, springs, studs, oversized valves. No real secrets in the head, nothing too fancy, but you know, all the good flowing stuff.
One of the things with the RB30 capacity upgrade, I mean, it's definitely not uncommon in the RB world. There's the purists that really want to stay true to the RB26 block, and there's also a lot of discussion about the relative strength between the RB26 and the 30 block. I mean, clearly you're making a lot of power on the 30 block, but is there any strength disadvantage to the RB30 block?
Look, we haven't done our own block testing to see what the limit is. We do work closely with Platinum Racing Products. He does a lot of testing with the blocks, even torque testing, to twist testing, to see like how far these things can stretch, and that's why he produces all the braces to go into the motor to prevent flex, which he believes is one of the biggest killers of these engines. So since we've been using his products, we haven't had any block failures as such, as far as twisting goes or etc.
So these braces that you're talking about, this is more than just an adapter for the RB30 to take the GT-R sump?
Yeah, it's integrated with the adapter, and also you can buy two types. There's like a girdle style, which is for all out. I'm not actually running the girdle style in this, and then you can buy the the brace style. So that's what I'm running in here. So.
Okay, so you're talking here about with the girdle, obviously that ties in all of the main bearing caps.
Right. Yeah, correct. Yeah.
All right, so moving on to the head, you've said you've had that ported, it's running cams, everything you'd expect there. One of the problems with the RB26 head, when you do want to run a decent large cam with a lot of lift, the head actually needs to be clearanced because the cam lobes interfere with the casting, that's correct?
Yeah, absolutely, yeah. So the piston, I mean, once it's all built, then we have to do a dummy assembly, check the piston and valve clearance, and if necessary, send the pistons back for fly cutting to suit.
And what sort of head gasket are you using here to hold the boost in?
Yeah, a lot of guys at this level are doing O-ringing and all sorts of things. We're still using a Tomei 1.2mm gasket with the decked block and the decked head and ARP studs. So theoretically at this power level we're probably taking a risk, but I like to witness firsthand when it's required for the next stage. So far it's been good.
Okay, so moving on from the engine block, the turbocharger is obviously another key to making that sort of power level. What are you running there and how much boost are you running?
Yeah, look, at the moment we've got a Precision 82mm turbo. The boost wise we're at 45 pounds, and we've also got nitrous on top of that. So
that's a fairly large turbo even for a 3.4 litre engine. What sort of boost response are you seeing with it? Where is it sort of making full boost?
Yeah, look, without the nitrous, in first gear taking off, we've got full, we're pretty much cracking gate by 6,000 RPM, which is good. So first gear we shifted at 92, so we've got a good whack in first gear to propel the car.
And with the nitrous, you're using that for anti-lag only, or are you running it the whole way down the strip?
Yeah, I use it the whole way. So I mean, we could use it just for spool, but because I like nitrous and I think the engine's quite happy to run the 100 shot that we've got in it, we use it from the start to the finish.
Now, in terms of getting traction with that package, can you run full boost right from first gear, or are you stepping the boost up as you go through the gears?
Yeah, look, a good question. Regulating power over speed or between gears is probably the key to having a quick car safely. So what we've got here, it depends on which surface. So I'm using an eBoost 2 to control the boost, and that's tied in with the ECU. So I've calibrated it so SP1 is first gear, SP2 second gear, SP3 is third gear, and SP4 is fourth gear, and then it's SP4 fifth and sixth after that. So pretty much what I do is when I go to an event, depending on the surface, if I feel like it's putting it down easily, then in that gear for that SP setting, I'll increase the duty cycle until it spins a bit and knock it back a few percent. So I basically just don't need the laptop. That's why I like the eBoost. Sits next to me. After each round, just come back, adjust a little bit here and there, first, second or third, whatever, which is the same thing happened yesterday. I had full power from second gear, which was working well on the street actually. So it was putting down full traction on the street and it felt good. But then when I came here, when I clicked first to second, it just blazed the tyres. So after the next round, I basically turned second right down and then had full power from third, and yeah, it did the trick.
So that's, I think, something that a lot of people overlook with a powerful car like this. It's always a balancing act, and often you've got more power than the car can put to the ground. So it's a balancing act of just getting that boost pressure and hence the power level suited to the amount of traction available. Another aspect that I did notice on the car that is a little unique, I guess, is that you're running no blow-off valve. Can you tell us about your reasoning for that?
Look, the reasoning for that, because it's primarily only used for straight line, plus it's a sequential gearbox, so even during a thrash there's no lifting. We had a bit of issues with the blow-off valves at the start, especially on high boost, leaking, not sealing. We had a couple of issues, and I thought, you know what, one less issue in the car is going to work to my advantage for as far as reliability and consistency goes. So yeah, we haven't had any boost leaks since then. As far as, if it was a circuit car on and off the throttle, I'd probably be adamant that I do need a blow-off valve, so I would look at a solution to what the issue was. Having said that, the last engine that we had a Precision 76 on it, and I think I've done about 15,000 Ks with that. And what happened was it developed a lot of thrust, which we noticed when we pulled it down. So it's possible that thrust is a result of not having a blow-off valve. But
I think that's one of the things that often in the aftermarket we're told the blow-off valves are there for boost response on a gear change, but the other aspect that's probably more critical really is that it relieves that thrust loading on the turbocharger on a gear shift, where the turbocharger has to release all of that boost back through the compressor wheel. So a lot with the later model ball bearing turbos as well, they're a lot stronger in thrust than the older turbos too. Now you've mentioned the gearbox briefly, and that's an important aspect of the fact you don't need to lift. So tell us what the gearbox is.
So we're running a PPG 6-speed sequential gearbox, which is a gear set that goes inside the factory, a standard R34 GT-R casing. So that's what we're running. They provide a load cell to go on that. So that's basically a gear knob with a load sensor inside it that puts out an analog voltage. I know you know, but I'm explaining to them. So that analog voltage goes into the Haltech, and then from there the ECU, the Elite 2500, does closed loop gear control. So the load signal goes into the ECU. We can set at what load the ECU will initiate an ignition cut. And then the ECU cuts it, looks at, there's another barrel sensor or a gear position sensor in the gearbox. So the ECU looks at the gear position. Once it's at the correct position, then it will reinstate spark. And that's how I do my flat foot shifting or gear cut. So that means that once I take off and my foot's flat from first gear, I don't have to lift the clutch anymore, and I'm just pulling the stick every time I see the shift light.
And that's obviously why you don't need that blow-off valve. The turbocharger with that flat foot shifting, the engine's essentially only off power very briefly for the shift, so it helps maintain boost with a large turbocharger. And just to reiterate as well, that closed loop control, it means that the ECU is looking at the gear position, and those gear cuts are only as long as they physically need to be for that next gear to be enabled. So this also ensures reliability of the gearbox here. Okay, so moving on to that ECU, you've mentioned the Elite 2500, that's controlling all of the functions. injections. I see you've also got flex fuel capability on the car. You're running that as well?
Yeah, absolutely. So the Elite 2500 pretty much does for full flex. So I've got a flex sensor in the fuel return line, tells the ECU the ethanol percentage, and then after tuning, automatically compensates for whatever ethanol value that I have. I do 99% of the time keep the car on E85. It is a bit of a guzzler, so sometimes I like to go for long drives on the weekend, and may not be able to get E85, but no problem. Go to BP, put 98 in there, keep driving. But yeah, obviously once 98's in there, I stay off the throttle. The Elite also is controlling staged injection, so we've got twin rail. We've got 2000cc and 1000cc. 2000cc on the primary, 1000 on the secondary. Should do it the other way around if you want a smoother idle, but I didn't want a smoother idle.
So particularly, this probably works quite well on E85 where you're using so much more fuel, but I imagine the 2000cc injectors would be a little bit marginal for control of the air-fuel ratio on pump fuel.
Yeah, absolutely, yeah. Once I get on to 98, the injector millisecond requirement is clashing with the dead time, so it does make for a lumpy idle and a bit of a jerky cruise, but I don't mind it. So if it was for a customer, before we decide which injectors we'll put in the primary, we'll ask them, do you want it to sound like a beast or do you want it to purr like a kitten? So.
Another thing that's quite interesting on this engine, I notice, is you've still got the stock Nissan cam angle sensor, and that's an area that's problematic for RB or Nissan tuners. I guess the SR is also an issue all around the world. So tell us a little bit about that. How are you getting by with that?
Yeah, look, it is problematic. With the earlier ECUs, like the Platinum Pros and all the earlier generation, not just with Haltech, but even with other brands, Lynx and whatnot, we never experienced any misfiring issues. We could always see a little bit of an RPM fluctuation at high RPM, like especially up around 8,000, but it never resulted in a misfire. And didn't have, string of engine blow-ups thinking, timing is an issue. So we got away with it, but then once the ECU manufacturers all started to bring out these whiz-bang trigger technology, they've started to measure down to the degree, and they're noticing that they can't calculate it because there's too much timing scatter. So most of people with the Elites and the other newer ECUs, not just Haltech, but Link and Motec, they all bring it up on the screen that you've got trigger errors at high RPM. So commonly everyone does crank trigger. We experienced this issue a couple of years ago when the crank trigger systems weren't readily available off the shelf. So we tried a crank trigger. We were one of the guinea pigs of some of the kits, and we had issues, and which were resulting in bigger trigger problems, violent bangs, and I didn't want to risk splitting a block in half because of tooth crossing at high RPM and whatever the issues were. So we resorted back to the CAS, but we swapped the 360 and 6 CAS disc with a AEM 24-in-1 CAS disc, and having less teeth or less pulses on there means less RPM scatter measured.
So you've got less chance essentially of the ECU getting confused with the harmonics that go in through the valve train and then into the cam angle sensor.
Exactly. So from doing that, we get a steady enough RPM signal right through to 9500, which is as far as we want to go with this engine. But ideally, yes, crank trigger is the next step for it. But yeah.
Trigger disc, however, much cheaper than going to a crank trigger system.
Look, it's not really, it is much cheaper, but a build like this, there's no price tag. Like it needs what it needs. We continued with the 24-in-1 disc mainly because it didn't have any issues with the last engine. The old 2.8 litre ran 162 mile, did 15,000 Ks, multiple events, never failed, still in good order. So I said, you know what, if it was good enough for that engine, let's try it on this one. So also I don't want to go all out off the bat because I like to try things in stages, a bit of development just to get my own feedback and data, so then I know what to offer the customer. It's easy just to roll out the catalogue to everybody and say, all right, you need 50 grand worth of staff, when, if we can genuinely get away with it for 35 grand and it's going to be reliable, then, I like to offer that.
I mean, often when it comes to modifying cars, you do need to work on the basis that if it isn't broken, then there's no need to fix it. Look, Adam, it's an amazing car, 960 kilowatts at the wheels, and a street legal application, regardless of the capacity or number of cylinders, is impressive. We wish you all the best for your final in the Turbosmart Flying 500 today, and thanks for the chat.
Yeah, thanks very much, Andre. Thanks, guys.
like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson. You'll learn about performance engine building and EFI tuning, and you'll also have the chance to ask questions which I'll be answering live. Remember, it's 100% free, so follow the link to claim your spot.